Okay, so in this video demonstration, I'm going to show you guys uh, how to look at a pattern and figure out in this case, the sixth missing term um, using the recursive formula as well as the explicit formula. So the first thing I got to do is look at my numbers here, okay, and figure out whether if I'm going to be using the recursive formula for the arithmetic sequence or the geometric sequence. So I got 6, 9, 12, 15, 18, so it's obviously increasing by 3 each time. We have what's called the common difference, the plus 3. So therefore, I know this is going to be an arithmetic sequence. Okay, so what I have here is the arithmetic sequence, the recursive formula for the arithmetic sequence written down here. And what I'm going to do is use that to figure out the sixth term. Now, most of you know what the sixth term is if you know the common difference. Um, basically we're going to simply just take the 18 and add 3 and get 21. But again, the goal here is to use the recursive formula and come up with the sixth term and prove that recursive formula will in fact work to figure out the sixth term. Okay, so that's our goal, so we're going to get started. I'm going to go ahead and take the formula. Now remember, the first thing you want to do is identify the f of 0 term. Okay, and so in this case, f of 0 is, well, the first term is 6. So f of 0 is the term before that. So f of 0 would be, if I'm backtracking, okay, so 6 instead of plus 3, I'll do a minus 3. So what I end up with is 3. Now for the recursive formula, I actually don't need this, but I am going to, if you notice down at the explicit formula, f of 0 is mentioned in the as part of the formula, so I'm going to need it. So just taking care of that right now. Okay. All right, so I'm going to keep that on the side. Okay, I'm going to go to the formula and copy paste. And what I'm going to do is basically on the copy I just made, I'm going to simplify some of these variables with numbers. So first of all, what is n? F of n. Okay. So I'm trying to find the sixth term. So the nth term in this case would be 6. So I'm going to go ahead and put a 6 in there. Alright, so remember, the overall process is basically I'm trying to figure out the sixth term by looking at the fifth term and adding 3 to it. Okay, so what I have here is, well, if that's the sixth term, um, and I want the fifth term, because remember, all I'm doing is adding 3 to that to come up with the next number. What I need to do is take the sixth term and go back 1. And that's where the n minus 1 is coming from. So 6th term minus 1 gives you the fifth term. Okay, plus the difference. And the difference is 3, so I'm going to go ahead and put that in. Alright, so simplify that. So now I can simplify that 6 minus 1 is 5. And what I have here is f of 5. So again, now what we're saying is, so the f of n minus 1 is really the fifth term. Okay, so what is the fifth term? 18. So I'm going to go ahead and type that in. Okay, and work this out. 18 plus 3 is 21. And there you have it. Okay, there's my sixth term using the recursive formula. Okay. Alright, down here I have the explicit formula. Okay, notice that f of n is the same, but this one does not use the previous term. It uses the very beginning term, which is f of 0, and then you're adding the difference after it's being after multiplying it to the term you're trying to find. Okay, it sounds a little confusing, but it'll make more sense when we do this. Alright, actually, so the first thing I want to do is actually bring down that down here, because that's really where I'm going to need it. F of 0, that's part of the explicit formula. So I'm going to first define that. F of 0 is 3. And remember, all we did was backtrack the first term. to the 0 term by subtracting 3 from 6. Alright, now I have, I'm going to go ahead and define n, and it's still the same. The 6th term I'm trying to find, it's the same problem, just a different way. Alright, so I have f of 0. What is f of 0? Well, I already did that up here, and I brought that down, so don't need to do that again. F of 0 is 3. Alright, now I have this d. The difference is still the same. Okay, same pattern, so I'm going to put 3. Alright, and then I have n. Okay, n again is the 6th term, so I'm actually going to go ahead and punch this 6 in. Now, notice that I have d and n next to each other. And hopefully all of you know that when you have two variables next to each other, it implies multiplication. Okay, now, so if I just delete that and put a 6, obviously that's going to mess this problem up because it's not 36, it's really 3 times 6. So what I'm going to do is, since I'm showing my work, I want to make sure that it's showing multiplication, so I'm just going to use parentheses. Now you can put a times sign if you want, it will have the same meaning. Okay? Alright, simplify that. Okay, let's see. So the question now here is, what do I do first? And remember, this just goes back to your pre-algebra skills of order of operations. 3 plus 3 times 6. What do you do first? Multiplication before addition, PEMDAS, right? No, PEMDAS. Multiplication, division, addition, and subtraction. Okay. So I'm going to go ahead and multiply 3 times 6, which is 18. Okay, and then you can see that it's pretty much the same ending that I had up here. 18 plus 3, 3 plus 18, same thing, 21. There. Alright, so I got my 6th term using the explicit formula. Okay, the last question I have to answer is it linear or exponential? Now in class I said all arithmetic sequences are going to be linear, but I didn't get a chance to show or prove that. So I want to do that real quick. And I'm just going to save some time by going ahead and plotting these on a, I found an online graphing calculator. I just Googled it and it came up. So I'm going to go ahead and use that. Basically, I'm taking the first 4 terms, 1, 2, 3, 4, 6, 9, 12, 15, and see what it looks like. Remember, a linear pattern is something that's going to line up. Okay, so I'm going to go ahead and do that. Alright, so here's this graphing calculator I found, and there are my points. 1, 2, 3, 4. These are my terms, and these are my so this is the first term being 6, second term being 9, third term being 12, again straight from the sequence of numbers we just looked at. And I graphed it, and there's the 4 points. Now obviously they do line up. Now the question is, why do they line up? It's just well, think about it. You have 1, 2, 3, 4 along the x-axis. That means they're all going over, their difference is the same each time. 1 over, 1 over, 1 over. Now, if you look at the y-axis, the difference is not 1, but it's still consistently the same. It's going up by 3. Okay, so what happens is you have 1 up 3, 1 over up 3, 1 over up 3. And what that's going to cause is a consistent pattern in where the points are placed, allowing them to line up. Therefore, these would be this would be an example of a linear function. Okay, so that is why. Let me see if I can get back to what I need to. Okay, and that's why arithmetic is always linear. Okay, in the next video I'll show you why geometric will come out exponential. Okay, and so if you need help with a geometric sequence, figuring the terms out using recursive and explicit formula, watch the other video. I hope this helped.